Okay, so the last video we kind of left off looking at how to draw a Lewis dot structure and how to actually get the formula, knowing, like if I'm looking at that first compound there, how I know that there's 3 sodiums and there's 1 nitrogen. So to just review a little bit, what we looked at was we looked at the charges. Oops. We looked at the charges, so if I've got Na 1 plus and I have nitrogen, which is 3 minus, what you do is you crisscross those charges, so the Na means there's 3 atoms, which is why I have a 3 there, and the N, there's 1 atom, so that's why I've just got the N written there. So you do crisscross charges. We're going to be reviewing that more today with this lesson, but this lesson is kind of moving into how to name an ionic compound. So when we are looking at something that is, I'm going to do this in red, when we are looking at something that is monatomic, mono means 1. So we're looking at 1 atom that is our anion. So if you haven't figured out what your anion is, it's your second element listed there. So this is my anion in each of these compounds. So when it's just monatomic, meaning there's 1 element, then the suffix is going to end in "ide." So we're going to name these with the last part of it. We're going to change the ending to "ide." So nothing happens to the cation. The cation stays Na stays sodium. So to name this first compound, I'm going to say Na is sodium, and I'm going to change the second part. So nitrogen, remember I want the "ide" there, so nitrogen becomes nitride. Sorry, I hope I get better with writing with this. It's a new stylus, so hopefully just bear with me and I can figure it out. On this second one, you've got Ca and you've got Cl. So I'm going to do this one in a different color. So again, the metal, nothing happens with the metal. We're just going to call that calcium. And then chlorine becomes, again, we need to change it to "ide, so it's going to become chloride. This should seem a little bit familiar to you because you did do this in physical science, but you know, if you're a new student or you didn't have physical science last year, then this may be something new for you, but most of you guys have seen this before. So again, this is when you have a monatomic ion. You're looking at the second element, just 1. So we're going to move on and do some more examples. So I've got Al2S3. So again, the numbers don't matter. The numbers are there because I crisscrossed the charges. So I've got aluminum, which is 3 plus. I've got sulfur, which is 2 minus. I know we'll have to review this when, coming back from break. Well, you're on Christmas break right now, but this video is being made, or you actually already did this before break, but I'm a little late on making these videos, so we will review this more, but you guys have all this stuff on your periodic table, so you can look it up. So crisscross, it would be Al2S3. But again, the numbers don't matter. When I'm trying to name it, this is just going to be Al is aluminum. And then I've got to look at what sulfur becomes. And again, it's monatomic because I'm looking at 1 element. There are 3 atoms of that element, but it is just 1 single element. We're going to move on to a polyatomic one in a minute. But this will become sulfide. And I'm making a mess over there. Let's erase that. And then the next one, I've got K2O. So if you look up what K is on the periodic table, K is potassium, and O is oxygen. So again, monatomic, so it becomes oxide. Hopefully you're getting the hang of it. Alright, so now we're going to move on and talk about what a polyatomic ion is. So the ending is no longer going to be "ide, it's going to be 8 this time. So polyatomic means more than 1. So you've got more than 1 element as your anion. So some examples that you saw in your last year course of physical science was SO4, PO4, CO3, OH, and NO3. I know that you use those, and I hope somewhat remember what the names of some of them. SO4, the way I like to try to think of it, it starts with sulfur, it becomes sulfate. PO4 is phosphorus, so that one is named phosphate. CO3 starts with carbon, so it's carbonate. OH, this is the one exception to the 8 rule. There's always got to be exceptions in chemistry. This one is called hydroxide. Don't ask me why it's not an 8, but they did make that one an ide. And then NO3 is nitrate. This one is new. We are going to have this in some of the examples that I worked today, so you might want to write this down. It's called ammonium. I'm not sure if we use that in physical science, but if you have not, you will use this again this year. So you're going to be learning a whole new list of the polyatomic ions. Yeah, I know you're excited, but please contain yourself. We are going to make a flip book whenever you get back to class, and you will not have to memorize these ions, but you will need to be able to look them up to get their charges, or if you need to know their names. So we're going to practice with a few examples. I know you don't have these. Most of the ones in the examples are ones that we used last year, so the ones that I have circled there. So we will practice, but then we're going to start working on some ones that you haven't seen yet, but we'll do that in class together. Alright, so the first one is NaSO4. So let's practice on crisscrossing the charges and making sure that we have the correct formula for this. So if Na, which is 1 plus, I can't get my stylus to work. Na is 1 plus, still can't get it to work. Na is 1 plus, and I cannot do that right. I'm having all kinds of trouble here. Maybe if I try a different color and rewrite it. So Na is 1 plus. And SO4, I think I had it on the slide before, but it is carrying a 2 minus charge. So some people in physical science get really confused by that 4 there on the oxygen. SO4 stays SO4. You don't touch it, you don't do anything with it, it just stays that way. What you are doing is exactly what you've been doing, and you're going to crisscross the charges. So this formula would become Na, there's 2 of them. SO4, there's only 1, so you just need to write it SO4. Some people in physical science want to put that parentheses there because sometimes they need it, sometimes they don't. In this one, you would not need it because there's only 1 of them. So if you have it, I'm not going to count it wrong, but I'm going to go ahead and erase it along with all my other stuff. So this formula was Na2SO4. Really sloppy. Let's try that again. Na2SO4. So naming this. So the only difference between monatomic and polyatomic is if you just got to be able to look up what that anion is, and you'll have your chart. You don't have to memorize it. But again, the first part stays the same. Na is sodium, so you name it sodium. SO4, we said on the slide before, that is sulfate. So the name of that compound is sodium sulfate, and that's it. On your next example, you have calcium and you have PO4, which is phosphate. So calcium carries a 2 plus charge if you look it up. Phosphate on the slide before was 3 minus. Again, you do not touch anything with the PO4. That just stays what it is. You're going to crisscross these charges. So it's going to become Ca3. And then you're going to write PO4 in parentheses. This time it will need to go in parentheses because there are 2 of them. Now, you cannot write this compound like this, because if you're looking at that carefully, it looks like you have 42 oxygens, and you do not. So this is incorrect. What you got to have is the 2 outside of the parentheses. What that means is you would take 2 times 4 to tell me that there are 8 oxygen, and then this is really a 1 for phosphorus, so it'd be 2 times 1, there are 2 phosphorus. When we get into balancing chemical equations, that's going to be really important to remember that. Alright, the name of this. You've got Ca, which is calcium, and you've got PO4, which we said on the previous slide, which will be on your chart when we make it. It is phosphate, and that's the name of it. Alright, 2 more examples, and then we're going to go ahead and stop with this video, and we'll work on some more of these next time. I've got Al, and I've got OH. So Al carries a 3 plus charge. OH is hydroxide, and if you look it up, it's 1 minus in your notes. So the formula for this would be Al, there's 1, and then OH, there are 3 of them. So AlOH3. Naming this one, Al is aluminum. It's really bad aluminum. Sorry. Hopefully you can read that. Aluminum, and then OH, remember, is our one exception. It's not an 8, but that is polyatomic because there's more than one element there. But the name of it is, really sloppy writing, hydroxide. I've been on Christmas break, so I haven't had to do work. Alright, the last example. You've got NH4 and you've got NO3. If you look up on your notes, a couple slides up, this was 1 plus, this was 1 minus. So again, you don't do anything with the stuff that I'm putting in parentheses. You are crisscrossing charges. So this is going to be NH4 1 and NO3 1. So really the formula is just rewriting those things all together as 1. The name of it, NH4, was ammonium, and NO3 was nitrate. And that's that compound. So I'm going to make another video. I may have you guys doing both of these together, but it's going to cover all the exceptions and what's going on with the transition metals. So right now I'm going to go ahead and stop this video and go ahead and get started with the next one.